Alright guys, we're looking at Newton's method, which is a way of finding roots or x-intercepts of graphs. We're using mind-ball mass. This is our source. So how Newton's method works, well, it can find all of these things. Basically, it can find any root of any equation. And all of these, if you're finding x-intercepts, you're going to let f of x be equal to 0, whatever, and solve for that. But all of these things, say you had two intersection of two graphs and you had f of x is equal to g of x. Well, really what you're going to find is an x-intercept of this equation. So in other words, you're going to end up with f of x minus g of x is equal to 0, and then you're going to call that new thing a name, and you're going to find the x-intercepts of that new equation. And if you're finding stationary points, so you're solving, let's say, f dashed of x is equal to 0, well, that's just an equation, so you'd give it some new name, let's call it h of x again. And you can turn any kind of root, any kind of equation, you can turn it into a function. And you essentially, Newton's method, once you've turned it into a function, Newton's method enables you to find x-intercepts of any function. In other words, which means that you can solve any equation. So how does Newton's method work? Well, say that's our function f over there, and your objective is you want to find the coordinates of point A. And they'll tell you to like 5, 6 decimal places, etc., etc. So you have to make an educated first guess. I mean, of where your x-intercept could be. You choose an approximate value. So let's say we made our first guess over there. This is obviously scaled up. Obviously it's not going to be at that point. So your x0 is going to be, that's your first guess. So you've got this point x0, f of x0. And then you go find the tangent at this point. So you find the tangent at x0. And you find the x-intercept of the tangent. And that's going to be your second guess, x1, right? Then you take the x-intercept of that tangent. And this becomes, you get the tangent at this point over here. So you have that point x1, f of x1. And you get that tangent over there, and where it cuts the x-axis, that's where your tangents cut the x-axis, is your next guess. So x2 would be my next guess. I go to that point, x2, f of x2. I draw a tangent, and it gets closer and closer, and you repeat that process. The fancy word in maths for repeat is iterate. Iterate means you do the same thing. You can never remember one or two T's. You do the same thing over and over and over again, and eventually you'll get as close as you want to A, to however many decimal places you want. We normally ask you for 5 or 6 decimal places. So Newton's method lets us find the x-intercepts. The way it does it is you draw tangents, and you find the x-intercepts of those tangents. And every new x-intercept is going to get closer and closer to the root of your equation. As you can see, you can only find one root at a time. You can only find one x-intercept at a time using this method. So that's the structure of this. Now just to discuss how we get the formula. So basically, how do we know, what's a simple formula we can get which will enable us to iterate this process of getting the next guess, the next guess, the next guess over and over and over again. Because if it's the same formula, we can use the equals button on your calculator over and over again. So say we wanted our first guess over here, we've got to a point, I'm going to use general notation, and this is a point xn, and so that'll be f of xn. So we're at this stage over here. It could be our 50th guess, it could be our first guess, whatever it is, it's a general guess. So what does the process involve? The process involves finding the x-intercepts okay, of tangents at that guess. So I go find a tangent at this point. Okay, and the x-intercept of the tangent will be my next guess. Okay, so my x-intercept of my tangent will be my next guess. Now, if I said to you that basically the method of getting the formula is two ways of looking at gradient. The one is, okay, well, the gradient of your tangent at this point xn, okay, would be equal to, well, we know the gradient at a point is a derivative at that point. Okay, so the gradient, okay, would be f dashed of xn. This gradient is equal to f dashed of xn. The gradient of a tangent at a point is the derivative. So we look at the gradient in two ways. However, the gradient of your tangent, okay, could also be thought of as change of y over change of x between any 2 points on that line. Okay, so if I took these as the 2 points I'm working with, then your change of y, okay, is equal to f of xn minus naught, which is f of xn. And your change of x over here between these 2 points is the x coordinate of n, okay, minus the x coordinate of n plus 1. So that's delta x. Okay, so the gradient is f dashed of xn, but we can also think of the gradient as being equal to, so the gradient of your tangent is also equal to change of y, which is f of xn, okay, over change of x, which is xn minus xn plus 1. So if you like, that's equation 1, that's equation 2. So I've got two things equal to my gradient of my tangent, so if I let them be equal to each other, okay, then I get, if 1 is equal to 2, then f dashed of xn, the one way of expressing the gradient, is equal to fx of n over xn minus xn plus 1. So what we're trying to figure out, we're trying to get, when I say we're trying to get the formula, as I say, we're trying to find, how do I get the next guess, which xn plus 1 is the next guess given the preceding one, which was xn over there. So we want to isolate xx plus 1, n plus 1 in terms of xn. So if I times this out, I get f dashed of xn is equal to, f dashed of xn times, get rid of the denominator, xn minus xn plus 1, okay, and that will be equal to f of xn. But what are we looking for? Okay, we're looking for xn plus 1, so I want to isolate xn plus 1, okay, this bit over here, so I divide by f dashed of xn. So I'm going to divide by that, and so I get xn minus xn plus 1 is equal to f of xn over f dashed of xn. Okay, you want to isolate that, so I'm going to move that to the right hand side, and move this to the left hand side, and I get xn minus f of xn over f dashed of xn, okay, is equal to xn plus 1. Okay, and so that's our formula. Xn plus 1 is equal to xn minus f of xn over x dashed of xn. And what all that will constantly do, it will give you your next x-intercept based on your previous x-intercept, so you can iterate. In other words, you can repeat that process. We're just going to use the equal button on the calculator over and over again, okay, until the decimals repeat to however many decimal digits we want. So this generates your next x-intercept, your next guess, okay, based entirely on your previous guess. Okay, it's just isolating the x-intercept. So this is on your information sheet. I actually think for some reason they write it as xr plus 1 is equal to xr, it's right at the bottom of the page, minus f of xr over f dashed of xr. That is on your information sheet. Okay, so Newton's method involves finding tangents. The tangents have to cut the x-axis, and we get closer and closer to the solution that you want. Okay, there are some problems, however, okay, with Newton's method, and really what they revolve around is the first guess. So your first problem you could have is, say that your first guess, okay, was a turning point of the graph. In other words, say you decided, you randomly picked a point, and it happened to be, okay, a stationary point of that graph. Well, what's our process? We find tangents at the point, and the tangent at this point is a horizontal line. Okay, it's parallel to the x-axis. So that would be a horizontal line. Okay, and the process, so the question would have been, let's say, find the coordinates of A. Okay, so your method of finding tangents and letting them cut the x-axis and repeating that process doesn't work, because this is never going to cut the tangent. So this is not going to work, okay, because your tangent is a horizontal line. Okay, horizontal, in other words, it will never cut the x-axis. Okay, so we can't generate x-intercepts, right? Okay, so the next process, okay, that we're going to do, okay, so that doesn't work. The other way you could look at it, I guess, is you could say, well, we know that xr plus 1 is equal to xr minus f of xr over f dashed of xr. So if you wanted to get x1 would be equal to your next guess after your initial guess, would be x0 minus f of x0 over f dashed of x0. And the formula breaks down because f dashed of x0 is the gradient at this point. This thing over here is f dashed of x0, that's your gradient. Okay? And if that's equal to 0, then in this formula we end up with 0 in the denominator, okay, and anything divided by 0 is undefined, okay, and the iteration, okay, will break down. So, your first guess, you're going to have to always make a first guess when you're using Newton's method. Okay, if your first guess is wrong, if your first guess is a stationary point, you're never going to generate x-intercepts, so the method's not going to work. Okay, the next problem comes if you pick the wrong point. If you pick a point on the function so that a tangent will not find the x-intercept we're looking for. So say the question says, we want to find the coordinates of A. Remember, Newton's method can only find one at a time. And you think, okay, I'm going to make a guess, and my first guess is going to be at x0 over here. The process involves taking the tangents and finding the x-intercepts of the tangents and repeating that process. So this, your first guess, would generate the next x-intercept of over here. You'd then go up to that point over here. This would be x1, right? And you'd draw the tangent in at that point. And so x2 would be here, right? Okay. Then you go to x2, and you draw in the tangent at this point, and where this method, when you iterate this process, it's going to give you B as your answer and not A. So we'll get the wrong x-intercept. So your first guess, well, this would work because this would generate it. Okay, has to be in the right position. If your first guess was over here, okay, you're going to obviously go find that x-intercept C. So you've got to find the right position, okay, an educated guess as to what your first guess should be. It can't just be random. Okay. Right. Draw a cartoon below to cheer yourself up. Right, and in the next video we'll start with actual examples.